All right, so to pick up where we left off, we were stretching our quadratic function. So we went 1 to the left, 1 to the right, but instead of going 1 down, we went 2 down because we wanted to stretch by 2. When I go 2 to the right, instead of stretching 4, because 4 is the normal amount of points I would go, I'm going to go 8. So 1, 2 to the right, and then down 1, 2, 3, 4, 5, 6, 7, 8. And again, because it's symmetric, once I put a point there, I can also put one here. So this makes my parabola really skinny. And my parabola looks really, really skinny, and it's going down because of that -2 that I had in front of my x plus 4 quantity squared. So that's my a value is -2. I do have solutions on this one. Solutions, again, when you actually are crossing the x-axis. So I do cross. I cross the x-axis at -3 and at -5. So that means I have a solution when x is at -3 and when x is at -5. Domain, again, I am going down left and down right. So because I went left and right, I've covered every possible x value from left to right, so from -infinity to +infinity. My range begins all the way down because those arrows are pointing downwards. So I start at -infinity and I come all the way up to my highest y value, which is right here, and that is +2. Remember, you read from left to right, so I'm increasing from -infinity to this x value right here, -1, 2, 3, 4. And then I decrease from -4 onward, so to infinity. And my end behavior, again, always starts off with as x goes to -infinity. So when I look to the left, my y value is going down. My arrow is going down. So I'm going to go to -infinity with my y value as well. And then as x goes to +infinity, so when I look to the right, my y value is also going down, and therefore it also goes to -infinity. All right, guys. Last but not least, let's look at one more together, also in vertex form. Transformations, because of the -1, I move right 1 unit. The -2 tells me I go down 2 units. And the 1/2 is that kind of stretch in the opposite direction. We call that a compression because it's going to make our graph wider than it really is, okay? Than the apparent graph, excuse me. So it's going to be wider than what our parent graph is. So a compression is what the 1/2 is telling us. That's like for a V shape, for the absolute value, that is our slope. For a line, it's a slope. For a parabola, for this quadratic function, it's not quite your slope, but sort of. It's kind of stretching and making your slope change less fast, actually. Opens up because your a value is positive because of this 1/2 that's here. It's a positive number. My vertex, again, is where I'm going to jump to next because my vertex is +1, -2. The 1 opposite from the inside of the parentheses and then -2 on the outside of the parentheses. I moved right 1 and down 2. That means my axis of symmetry is +1. I'm going to pause here and I'm going to put my vertex at 1, -2. I am opening upwards because it's positive, but I'm opening up by 1/2. So when I go to the right 1, I would normally go up 1. But instead of going right 1, up 1, I'm going to go right 1, but only up 1/2 because I'm wider. At the 1/2 is going to make it wider. So I go right 1, up 1/2. Left 1, up 1/2. My parent function, when I went to the right of the vertex 2 units, I went up 4. Well, now I'm going to go half of that. So now when I go to the right 2 units, I'm going to go half of 4, so it's only going to be up 2. So right 2, up 2. Left 2, up 2. So my parabola is going to start to get wider. And it's wider than what my parent function started out at as well. Now you guys know that we can find these points on our calculator as well. We'll do some practice with that in class. But just so you guys can start without a calculator, we can think of these as getting wider or skinnier depending on what changes we have to our parent function. We also have solutions for this one because we do cross the x-axis at 2 points, at x equals 3 and at -1. My domain again is -infinity to infinity. My range begins at where is my vertex? Right here, at -2 is my lowest y value, and then I go up to infinity. I am increasing from this x value right here, which is from 1 to infinity. I'm decreasing from -infinity to 1, and then my end behavior. As x goes to -infinity, so when I look to the left, my arrow is going up, so my y value is going to positive infinity. And as x goes to positive infinity, so as x goes to positive infinity is when I look to the right, my y value is also going up to positive infinity. So you guys have been graphing quadratic functions, and I just want to take you guys on a little review. You can pause the screen again here at any time that you need to. I wanted to show you guys what we've basically been doing so far, right? What we just did was a quadratic. So this one is a quadratic. Down here you'll see absolute value. And then down here is linear. So this is a little review of all 3 graphs that we've done so far. Quadratics look like a U shape. Absolute value is the strong V shape, and then linear is going to be some kind of line, right? The difference on these is that you guys notice an inequality. So that means we are going to have either a dotted or solid graph, and it's also going to have some kind of shading. So for this one, I'm going to go left 1, down 2. I'm going to have a negative opening, but it's the parent function. It hasn't been stretched at all. So I am going to go 1 over, 1 down, and then I'll go 2 over and 4 down. Remember, those are our units for the parent function. Because it's just greater than, I have a dotted function, and greater than means I'm going to shade above. Whereas with this absolute value function, I move 3 to the right and 1 up, so this is where my V is going to start. I am not stretching at all, and I'm not reflecting, so I'm going to go up 1 over 1. And remember, my slope does not change for an absolute value function, so it is up 1 over 1 the entire time, so it makes a strong V shape instead of the curve. Because it's less than, I am also going to keep it dotted. And less than means I'm going to shade below, which sort of looks like outside on this one. Last but not least, let's look at our linear function. My y-intercept is 1. My slope is -2, and then to the right 1, or divided by 1. So I'm going to go down 2 to the right 1, or up 2 and to the left 1. It is underlined. It is greater than or equal to. So now I have a connected, I'm going to connect my dots on here. And if I put my finger on the line, it is greater than, so I'm going to go up, and I will choose the side that is above the line to shade. So that means all of my solutions are in those shaded areas of these graphs. That's it for tonight. I will see you guys next time.